Hello everyone, welcome to AP Calculus. This is 30 most important question series on area bounded by polar curves. So this is the question number 7. Find area of common interior of r is equal to 3 cosine theta and r is equal to 1 plus cosine theta. So first of all, let's draw the graph of both of them. So r is equal to 3 cosine theta. That is going to be a circle having a diameter of 3 and axis along the positive x-axis because it is the cosine. So this will be a circle for this, and this is 3 over here. Similarly, for r is equal to 1 plus cosine theta, that is a limacon. Here a is equal to 1 and b is equal to 1. So a upon b is equal to 1 over here. Since it is 1, so it will be a limacon with a dimple shape. And since it is 1 plus 1, there is a plus over here, it means it will open along the positive x-axis. Major part will be positive x-axis, and the graph will be like this. And this is 1 plus 1 is going to be 2 over here. So this is 1 and this is 1. So we have to draw both of them in the combined format, and we will find the area of the common interior of both of them. So if you draw in a combined way, it will be like this. This is the r cosine theta, 3 cosine theta, and the other one is going to be like this. Now it is asking the common interior. So common interior means this region. Now first of all, we have to find the radial lines over here. Now what will be the radial lines? So to calculate the radial lines, we should equate both the r values. 3 cosine theta is equal to 1 plus cosine theta. So we'll say 3 cosine theta is equal to 1 plus cosine theta. 2 cosine theta is equal to 1. So cosine theta is equal to 1 by 2. If it is 1 by 2, so we know theta is pi by 3. So this particular radial line is pi by 3. According to the symmetry, this one will be minus pi by 3, we can say. Now we have to find the area for this and for this. Similarly, this region and for this region. Now since you can see area above the x-axis and below the axis are exactly the same, so we'll find the area only above the x-axis and we will double it. But again, we can see this is the 0 and this line over here is pi by 2, because the radial line for this circle means for 3 cosine theta, if you put this is equal to 0, the cosine theta will be equal to 0 and theta is going to be pi by 2. So pi by 2 is the radial line for the circle. We will do this calculation in two parts, because in the 0 to pi by 3 you can see only this blue line is there. So blue line means it is the region bounded by this limacon, and from pi by 3 to pi by 2 it is bounded only by the circle. So we'll break the integral in two parts over here, because it is not outside minus inside. There are two different curves. So we will say first integration 1 by 2 from 0 to pi by 3, and which is this blue color curve, that is the limacon, which is 1 plus cosine theta. So we'll do 1 plus cos theta whole square d theta. Then we will again find the area from pi by 3 to pi by 2, and this is the circle over here, which is 3 cosine theta whole square. Now whatever answer you will be getting, we will multiply the complete answer by 2. Why we are multiplying the complete answer by 2? Because this expression will give us the area only for the above the x-axis, but it is below the x-axis also, so we'll multiply it by 2. So final expression will be this. If you distribute this 2 inside, so this 1 by 2 and this 1 by 2 will get cancelled out. So we'll be getting the final expression for the area will be 0 to pi by 3 1 plus cosine theta whole square plus pi by 3 to pi by 2 3 cosine theta whole square. So when you put this expression in the calculator, you will be getting the direct answer from the calculator, which is 3.926 square units. Now, if you want to do the same calculation again, in the previous question we have done the similar type of calculation. If you want to do it manually, just open it by 1a plus b whole square and replace the cos square theta as 1 plus cos 2 theta by 2, and then you can integrate it. If you want the detailed working, just comment down below and I'll share the detailed working also. So if you have any other doubt related to the AP calculus, you can message on this particular email. Thank you for watching.